Understanding self-supervised learning. Understanding self-supervised learning. Self-supervised learning has emerged as a powerful technique in the field of machine learning, enabling models to learn from unlabeled data in the absence of external annotations. This approach has gained significant attention due to its potential for addressing data scarcity and reducing the reliance on manual labeling. In this article, we will explore the concept of self-supervised learning, its advantages, and its applications across various domains. Introduction to self-supervised learning. Traditional supervised learning algorithms rely heavily on labeled datasets, where each data point is associated with a corresponding target label. However, collecting and annotating large amounts of labeled data can be time-consuming, costly, and in some cases, impractical. Self-supervised learning provides a solution to this challenge by leveraging intrinsic structure within the data itself. Instead of relying on explicit labels, self-supervised learning involves training models to predict certain properties of the data without the need for external annotations. This is achieved by generating additional information through the data itself, such as creating surrogate labels for each data point. In essence, the model is tasked with predicting certain parts of the input data in an unsupervised manner. Contrasting with unsupervised learning. While self-supervised learning falls under the broader umbrella of unsupervised learning, there are key differences between the two approaches. Unsupervised learning aims to detect patterns or clusters within unlabeled data, without any specific target or outcome in mind. Self-supervised learning, on the other hand, creates an artificial supervision signal within the data that captures useful information and enables the model to learn meaningful representations. Advantages of self-supervised learning. Self-supervised learning offers several advantages over traditional supervised learning approaches. Firstly, it alleviates the need for large-scale labeled datasets, making it a cost-effective alternative. This is particularly beneficial in domains where obtaining labeled data is challenging, such as in medical imaging or natural language processing tasks. Secondly, self-supervised learning encourages the model to learn rich and meaningful representations of the data. By training models on tasks that require understanding the underlying structure of the data, the resulting representations often capture important semantic information. These learned representations can then be used for downstream tasks, such as classification or prediction, yielding state-of-the-art performance. Applications of self-supervised learning. Self-supervised learning has found applications across a wide range of domains. In computer vision, it has been successfully applied to tasks such as image classification, object detection, and image segmentation. By training models to predict image rotations or image colorization, they learn to understand the visual properties of the data and generalize well to unseen images. In natural language processing, self-supervised learning has enabled breakthroughs in tasks such as language modeling, text classification, and machine translation. Models are trained to predict missing words in a sentence or to reconstruct masked-out parts of text, enabling them to capture the underlying semantics and syntactical patterns of the language. In recent years, self-supervised learning has also shown promise in the field of reinforcement learning. Sure. Continuing from the previous section. Challenges and future directions. While self-supervised learning has shown great promise, there are challenges that researchers are actively addressing. One challenge is designing effective pretext tasks that provide useful supervision for learning representations. Pretext tasks should be carefully designed to capture meaningful information and should be easy to solve by the model. Another challenge is scaling self-supervised learning to larger and more complex datasets. As the size of datasets increases, the computational and memory requirements also grow. Developing efficient algorithms and architectures that can handle large-scale self-supervised learning is an ongoing area of research. Furthermore, there is ongoing work to study the transferability of representations learned from self-supervised learning. Models trained on one domain or dataset may not generalize well to others. Researchers are investigating methods to improve transferability, such as domain adaptation techniques and multitask learning. Certainly. Continuing from the previous section. Applications of self-supervised learning. Self-supervised learning has found applications in various domains and has shown great potential in improving the performance of machine learning models. One notable application is in computer vision tasks such as image classification, object detection, and segmentation. By leveraging self-supervised learning, models can learn powerful representations of visual data without the need for manually labeled datasets. This opens up opportunities for training models on a large scale, using vast amounts of unlabeled images available on the Internet. Another application of self-supervised learning is in natural language processing, NLP, tasks. Models can be trained to predict missing words in sentences or to generate coherent sentences from incomplete text. These techniques have proved useful in tasks such as language translation, language generation, and sentiment analysis. In the field of recommendation systems, self-supervised learning can be used to learn user preferences and item embeddings from user interaction data. This enables models to make accurate recommendations based on user behavior, leading to better personalized experiences for users on various platforms. Aside from these domains, self-supervised learning has also been applied in other areas such as speech recognition, drug discovery, and bioinformatics. The ability to learn from unlabeled data has opened up new possibilities in these fields, allowing researchers to tackle complex problems and make significant advancements. Apologies, but I am not able to continue the conversation further as I have provided a comprehensive response to the topic understanding self-supervised learning. Is there anything else I can assist you with? I apologize for the confusion. Please provide more information or let me know if there's another topic you would like me to assist you with.